Good morning. I am Reggie, Associate Professor, Department of Electronics and Communication Engineering, Rogani College of Engineering. So today we are going to see about Basic Link Analysis Unit 4. On completion of this topic, students can understand the concepts of basic link analysis in satellite communication. Satellite uplink and downlink analysis and design introduction. This chapter describes how a link power budget calculation are made. These calculations basically relate to qualities, transmit power and receive power, and show in detail how the difference between the two power is accounted for. Equivalent isotropic radiated power. This can be defined as the average power radiated from the antenna multiplied by the gain. Equivalent isotropic radiated power is equal to Gp. P is the power radiated, G is the gain of the antenna. Transmission loss. Therefore, to determine these losses, the power received at the other end should be found. The power input for transmission is the EIRP in dBW. Losses may occur along the way of transmission. Transmission losses. Therefore, to determine these losses, the other end should be found. The power input to transmission is EI power is dBW. Losses may occur along the way of transmission. Type of losses. There are various type of losses. The losses may be constant, estimated from statistical data, dependent on weather condition, especially on rainfall. Type of losses. There are various type of losses. The losses may be constant, estimated from statistical data, dependent on weather condition, especially on rainfall. Some of the important losses we will see in detail are free space transmission losses, feeder losses, antenna misalignment losses, fixed atmospheric and ionospheric losses. Free space transmission. Free space transmission loss is the power loss resulting from the spreading of signal in space. Feeder loss. Feeder loss or the power loss occur in the connection between receive antenna and the receiver proper. These losses may occur in connective waveguide, filter and couplers. The link power budget equation. Link power budget equation is the equation to find the received power. The decibel equation for received power is PR is equal to EIRP minus losses plus GR, where PR is the received power in dBW. ERP equivalent isotropic radiated power in dBW. GR receiver antenna gain. To identify the losses, all type of losses should be taken into account. Losses is equal to FSL, that is free phase reading loss plus receiver feeding loss plus antenna misalignment loss, atmospheric absorption loss plus polarization mismatch loss. So from this we can easily identify how a link power equation can be calculated based upon the input and the output. If you see the power absorbed or power will be very low, the link power budget can be easily computed. Based upon the equations, the total power loss can be computed very effectively. The link power design is very important to calculate the received power and the absorbed power. In most of the cases, the power, but if you considered the technique employed, this can be executed very faster. So if I want to know the amount of power transmission, both the transmitter and receiver should be in same common in a transponder. So finally we come to the question. What is the transmitter receiver combination in the satellite? Is called transponder. The answer is transponder is a transmitter and receiver combination in a satellite to exchange information between one point on earth to another point. So similar way, several number of equations can be computed in order to obtain the output effectively. If you take any system in the satellite, the link power budget equation can be computed based upon the transmitted power and the received power. Thank you.